In this video, I'm going to be removing this wall AC unit because there's a problem with excessive noise coming from the fan. You can hear it. Very, very noisy. So I'm going to be removing this from the wall, opening the unit up to find out why I'm having that problem. It may be just a bearing that's rusted out. I'll have to change it. But since I'm removing this from the wall, I'm also going to show you how to troubleshoot numerous parts inside the AC unit in case you're having problems with your wall AC unit. So let me take this out of the wall and then we're going to take a closer look. Okay, the air conditioner has now been removed from the wall. I took apart the cover that went over the entire unit. Now what I'm going to do, before I go to correct my problem with the fan, I want to go over the entire air conditioner, explain exactly how it works, because you're going to need an understanding of how the air conditioner works before you can actually fix it. It doesn't pay for me to show you how to check certain things if you don't understand how the system works. It makes no difference if your air conditioner is operated with switches like this or an electronic control. They all work the same. The only difference is the one with the electronic control uses temperature sensors and relays to turn on the fan and the compressor. This coil you're looking at right here, this is your evaporator coil. This is where the cold air is produced. The air is drawn in through the front of the evaporator. It's cooled, and then it comes out the top here from the fan and blows back into the room. This part right here is your temperature sensor. Inside this tube is a fluid or an oil which responds to temperature. If the temperature rises, the fluid inside this tube will expand, and if it gets cooler, the fluid inside the tube will contract. And with this air conditioner, that is what turns the compressor on and off. That's what regulates the temperature. I'm going to spin the air conditioner around now for a different angle. I'm also going to remove this cover. Now before I get into explaining what these components are and how to test them, I would like to carry on and explain exactly how the system works. So you have the evaporator, which I just explained, is where the refrigerant becomes cold to cool the air in the room. The job of the compressor is to take the refrigerant, in this case it's R410A. There are many different types of refrigerants and they all operate at different pressures. When the compressor turns on, it compresses that refrigerant into a high pressure, hot gas. That high pressure, high temperature gas then goes on to the condenser, which is right here. Let me show you the condenser. It's a large coil. As the refrigerant leaves the condenser, it should be full of liquid, this line. So you're going to end up with a high pressure liquid line. It went in as a gas, a high temperature hot gas, and it leaves as a high pressure liquid. The only way this line, this is called a capillary tube. It's extremely small, the inner diameter of this tube. The only way this tube will be full of liquid is if you have the proper cooling, if the fan is working properly, and if the system has a full charge. If the system does not have a full charge, you're going to end up with a line that's going to be very spotty. You're going to have liquid and gas, and your cooling is not going to be efficient because you're low on charge. The only time you end up with a low charge, normally, is if you notice that your evaporator or condenser coils develop a leak at the bottom. The only way to fix that leak would be to add a tap valve on the low pressure and high pressure lines from the compressor. That valve looks like what you see right here. Once those valves are installed, you can then repair or replace any parts as necessary. When you go to put the part back together, you're going to have to use an inert gas. The gas is going to go inside one of your fittings, and you're going to leave the other fitting slightly cracked. You're going to apply a low pressure and make sure that low pressure flows through all the tubing. The purpose of putting the inert gas inside the tube is to prevent scale from forming when you go to braze the copper back together. You don't want to have any scale. That scale is like a very fine powder, and once it gets into this tube, your system is completely blocked. So it has to be done right. That's a completely different video. I just wanted to give you a little idea of what had to be done in the event of a leak. The high pressure liquid then inside this tube goes all the way over to the evaporator. When it goes from that little tiny tube into a larger tube like you see here, you're going from a high pressure into a low pressure area, because this side of the system has suction from the compressor and the other side has that little tube which is very high pressure. Going from high pressure to low causes the refrigerant to become very cold, and then when the air flows through, that's how you cool the room. So it's a very simple system. Every air conditioner works basically the same. If you have a heat pump, the only thing that's different, there's a reversing valve on the refrigerant line. Instead of sending the high temperature hot gas over to the condenser on the back of the unit, it sends it to this part here, the evaporator, so this becomes hot and then the other side becomes cold. Now in this case, I removed this from my room because the fan was making noise and it looks like there was just some rust scale wrapped around the shaft close to the motor. So I'm going to scrape that away and apply some oil, a few drops on each side of the motor, which I'll show you in a minute. If that resolves the problem, I'll be okay. If it doesn't, I would have to disassemble that motor and just install 2 new bearings on the motor, which is very easy to do. Knowing how the system works, now I'm going to get into how to test certain things. Let me get a little closer here. Alright, over here is the temperature control for the unit. If you notice on top, you have 2 blade connectors, and then you have where the tube goes to the front of the evaporator to sense the temperature. In order to test this, the best way to do it is you're going to remove the 2 blade connectors on top. Makes no difference where they go. You're going to take a digital multimeter. You're going to put it on a continuity setting. Let me put that right there. Hopefully you can see it. Alright, so when I touch the probes together, I have continuity. You're also going to need a few jumper wires. It makes life easier. Going to connect one to one of the blades. There. And let's take the other one. Other blade. Alright, right now you can hear the continuity alarm running. Right now it's indicating power would be flowing to the compressor to allow the room to cool. So I'm going to put this back on. Go each direction. Alright, it's staying on because the room is hotter than the lowest setting on the thermostat. Take an ice cube and you're going to hold it right over the end of that bulb. Alright, now the switch is able to work. Let's see if it clicks off again in a minute. As it gets colder, it should click off. There you go. That's how you test them. They're very simple to test. If it passes that test, you can rule that out, so you can disconnect this and move on to the next thing. And move this out of the way. Let me put the blades back on. Let's put these blades back on here. Make sure when you push them back on that you're not going between the rubber and the female blade. You want to go into the female blade. You can hear that clicked in nice. Let's do this one. And both are in. You heard that just click a minute ago. As the end of that bulb warmed up, the thermostat clicked. See, now it's clicking. Alright. Now the switch, every switch is going to have different terminals on the back, so I'm not going to show you how to test on this one because more than likely yours is going to be different. But what you're going to have to do, using the continuity tester that I just showed you, you're going to remove the blades on the back of the switch. On this one there's 4. One is usually a common, and you're going to probe between one terminal and the other. And you're going to turn the switch on, to make sure the continuity alarm comes on and off. And there's a setting for low fan and high fan, and then there's high cool, low cool. Keep in mind, the compressor runs the same on high cool and low cool. The only difference is the fan. The fan will be lower on low cool, and on high cool the fan will be faster. So you just want to probe the terminals on the switch to ensure that they're working properly. Make sure all your grounds are connected good, that there's nothing loose. You're also going to want to inspect all your blade connectors. You could pull them off and put them back on. Make sure there's no corrosion. I've seen many times things stopped working because of a very poor connection on a blade connector. This round canister at the top with the 3 terminals is called a dual capacitor. It's an oil-filled run capacitor. It's used for starting the compressor up, and it's also used for running the condenser evaporator fan motor. The first thing you want to do before we test the capacitor or touch any of the wiring, you always want to make sure the capacitor is discharged. Also make sure your unit is not plugged in. In order to discharge the capacitor, I made this little capacitor discharge tool you see right here. This is a 20 k ohm 5 watt ceramic resistor made by Ohmite. You can use a 5,000, a 10,000, or a 20,000. Just make sure the wattage is sufficient. What this is going to do, it's going to allow the capacitor to bleed off any charge. The capacitor can hold a lethal charge, so you want to make sure you drain that capacitor down before you touch it. You're going to take that tool, connect one end to the ground. The other end is going to go to the blade of a screwdriver. Hopefully it stays in position. And you're going to touch it to each terminal for about 5 to 10 seconds. You do that one. When that's done, you do the next one. And then you go to this one. Once you've done all 3 terminals, you're going to put this on the common terminal, which is right there. Hold it by the insulation. Don't touch anything else. And then just touch to the compressor, in this case, which is the blue wire going to the black terminal. And then you're going to take the same thing and touch it to the red. That's the terminal that goes to the fan. Once that's done, for added safety, take a pair of needle nose, and then you're going to want to try shorting between each one, between the compressor and the common, and between the common and the fan. Don't touch any metal parts of the pliers while you're doing this. Once that's done, now it's totally safe to touch that capacitor. Going to slide the capacitor out. Should slide out. Alright. That's what it looks like. Alright, the value of this one is 35 microfarads. That's for the compressor. And 6 microfarads is for the fan. Your values may vary, but the capacitors all do the same thing. Now, in order to test them, make sure you label each wire and mark where it goes on the capacitor. If you don't have colors, usually you will see a C by the common, and then you might see F for fan, and an H next to the one for the compressor. I'm going to pull these off. Alright. I know the shorter one with the blue goes on the red. Put this down for 1 minute. Give you a better close-up. Bring the camera down. Because the average person does not have a tester for measuring the exact value of the capacitor, I'm going to show you how to do it using a digital multimeter with a resistance setting of around 20 megs. Let's put it on that. Now you're going to go between each terminal and the can. When you put it on a 20 meg setting or higher, you should see absolutely nothing happen to this meter when you touch between each terminal and the can. So let's do that first. Alright, and let's do it here. And let's go in between that one right there. I'm on it. And as you can see, nothing. So that's good right there. The other test you're going to do, you're going to leave it on the high range setting, at least 2 million. Higher is better. I'll be using 20 million. You're going to check between the common terminal and the fan, and the common terminal and the compressor. You should see the values start out very low and then rise way up into the millions and off into infinity if the capacitor is good. Here we go. It's a good idea to short out the two terminals you'll be testing right before you do this test. And that continues to climb as well. If you don't short them out, it may start a little higher, like you see on this one. See, it's already around 8 million. So what you would do, just short them out. And then you could try it again and you'll see it'll start low. See? So this is a good capacitor. You could rule that out if there's any problems. If you go to turn on your air condition and you hear the compressor running, but you don't hear the fan running, it's a very good possibility you have a faulty capacitor or faulty contacts on the switch that turn on the fan, or, which I've seen happen many times, is from not using the air conditioner for a while, the shaft will actually seize up in the motor for the fan. So you grab a pair of pliers and you just wiggle that shaft back and forth to free it up. Apply a few drops of light oil to each side of the shaft on each side of the motor, and you should be good to go. If you go to start the air conditioner and the compressor does not work but the fan does, and you already made sure that the thermostat is working properly with the ice cube test, then you're going to want to test the capacitor between common and H, and you're going to want to test out this switch. If the switch terminals are okay and the capacitor is okay, you're going to want to test the windings on the compressor next. I'm going to show you how to do that right now. To test the compressor, we're going to remove the cover protecting the terminals. On this cover, it's showing 3 terminals under here. It says run, start, and common. So let's take this off. Of course, the capacitor must be discharged before you touch anything. Let me loosen this because it's kind of stuck on there. All right. This part right here, I'll show you in a minute how to test it. This is a thermal cutoff. In the event the compressor gets too hot, what will happen, it will interrupt the circuit and turn off the compressor. Over here we have the 3 terminals. I'm going to move the camera, give you a better angle. Here's the cover showing. Alright, that's the run winding, that's your start winding, and that's the common. Over here is the thermal cutoff. I'm going to slide up the terminals. That's one. Push it out of the way. I'm going to take the black one right here. Slide that out of the way. Give it a wiggle. Keep in mind the connection here could be corroded as well, causing the compressor not to get the full amount of current to get it to turn over. So make sure these connections are very clean, especially when you put them back. There you go. Alright, so this will be out of the way there. Now that everything's disconnected, I'm going to put my meter on a 200 ohm range. Place it right here. Now we're going to test the resistance between the common and the start and the common and the run. Now the values will vary greatly between different compressors, but in general you should see a low reading. That's 2.6 ohms, and this one on the run is lower, around 1.6. If you measure the resistance on the compressor between the run and start terminals, you should have the sum of the two windings. The next test to rule out the windings as a problem, you're going to check from each one of those terminals to the body itself, just like the capacitor. So I cleared away a little area right here to make sure it's a good connection, and you check from each one on a 2 meg or higher setting. I'm using a 20 meg. None of these terminals should affect the reading on the meter. It should stay infinity as you see. If you get any readings on the meter that's going to indicate faulty windings, you're going to want to replace the compressor or toss out your air conditioning unit. Now over here is the thermal cutoff. Put this on a continuity setting or a very low ohms range. Right now touching the probes. You want to check between the terminal and the wire here. Right now there should be continuity because this switch is not hot enough to make it an open circuit. So I'll hold it there. Doesn't make a difference with my hands on it. We're not doing a high resistance test. And touch it to the blade. That's excellent. If you were checking that right now and the unit was cold and that did not have continuity, that's going to indicate that the thermal switch is faulty. You're going to want to swap that thermal switch out with a new one. I'm going to put this all back together and we're going to go take a look at the fan motor next. The blade connectors are now back onto the compressor as well as the thermal switch. The cover's bolted down nice and tight. Now before I go show you the fan, I wanted to show you one thing here. This part you're looking at, it's about 1.25 inches in diameter. It's about that long. This is called a suction filter. What it does, it filters the refrigerant as it's being drawn back into the compressor. There's a desiccant bag in here which absorbs moisture from the refrigerant if there's any in there, as well as any debris. You don't want any debris. Like I said earlier, the debris can easily clog small tubes like you see right here. There is one more thing I would like to mention regarding the compressor. It is very possible that if everything tests okay, the windings, the capacitor, and all the connections, that your compressor may be stuck. The only way to free the compressor from being stuck, with the air condition powered on, you would take a rubber mallet and with light to moderate blows you are going to strike the side of the compressor, the body of the compressor. It's a very thick steel. You should not be able to damage it as long as you use light to moderate blows with the rubber mallet. Many times in the past I have had great success doing that and freeing up a compressor. If the compressor gets stuck again in the future, the only other thing that you can do would be to add a hard start kit. You will connect what you see in this image right here across the existing capacitor for your compressor. What the hard start kit will do, it's going to supply a lot more torque to the motor to get it to start up easier. And that's really your only hope for a compressor that has a tendency to stick. Otherwise you're going to have to replace the compressor or throw away the unit. You're now looking at the fan. I'm going to remove this styrofoam shroud that directs the airflow back out into the room. Just going to lift it up and off. Here you can see the squirrel cage, and over here is a regular fan. So as this rotates this way, air is being drawn in through the holes in the side of the unit, and it's being directed out the back so all the heat can be removed from the condenser. And as this one here spins, it's sucking the air through the evaporator. Now there is a little bit of a sound that was amplified before when I turned it on. Let me do it again. You can hear it. I'm going to oil the bearings in a minute, and hopefully that does the trick, because if it doesn't, I'm going to have to open up this little motor here to replace those bearings. Now over here, if you go to turn on the air condition and the fan doesn't work, but the compressor does, and you did rule out the capacitor and the switch as being a problem, the next thing you're going to have to do, besides check any connections, is test the windings on the fan motor. Now there's a diagram right here. I'm going to zoom in so you can take a look at that. Now we're going to take a closer look at the wiring diagram on the fan motor. M is the motor. Off the motor is a blue wire which goes to a thermal cutoff. This is 130 degrees Celsius, and that connects to the power. In the event this gets too hot, that switch opens, turning off power to the fan motor. It's also possible, just like the compressor, that thermal switch could be faulty, which is internal, and that will prevent the motor from working. In order to test that, you would have to disassemble the motor. There's screws all the way around. Separate each half to be able to test it. There's a black wire right here which goes to the capacitor. The capacitor is connected between the black wire and the blue after the cutoff. You have a white wire. That's your, see there's an L after it. That means low speed. If you want the fan to run low, you would have your AC line, 120 volts, connected between this point here and the white, which is the L. If you want high speed, it would go between the blue and the red, which is high. You can see the H. We're going to check between the blue and the black. We're going to check between the white and the blue, and we're going to check between the red and the blue. And of course, we're going to check from each one of those wires to the housing to make sure there's no shorts inside the motor. To do that, I'm going to spin this around so we can look at the wire harness. Now the wire coming, this is from the compressor. The one that I want is right here. It's these 5 wires. The ground wire, and then we have the red, the blue, the white, and the black. So let me follow these wires to where they go. To test the winding, I'm now going to refer to the diagram on the motor again. Between red and blue is the high speed. So let me push this on blue. Let's go to red. That's around 140 ohms. 0.140 k ohm is 140 ohms. Now I want to check between the white wire, which is the low speed, and the blue. Let's put this here. That's 154 ohms. And now I want to check between the black and the blue. That's where the capacitor would go. So let's get the blue here. Blue. And connect that to the black. 238 ohms. Now these values, of course, will vary depending on the model fan that you use. If you want to find out what the ranges are, you're going to have to refer to the manufacturer for your particular fan to find out what the values are. Now for the final test for the fan motor, you're going to check between each one of these blade connectors and the housing of the motor itself. So I'm going to touch that there. We're going to go to here. You should see absolutely nothing. We're going to go to the red one. Absolutely nothing. Let's go to the white one. Nothing. And you're going to go to the blue. Nothing. If you observe any change in the meter between any of these blade connectors and the housing of the fan, that's going to indicate a fault in the winding. The last thing I'm going to do is show you where to apply oil to the fan motor. On some condenser fans or dual shaft motors like you see here, on the part of the motor where the shaft sticks out, right over here, you may see a little tiny plug on the side. Normally what you would do is you would pop open that plug and apply a few drops of very light oil, like a 5 or a 10 weight oil, and you would do it on both sides. Now in this case, it's a cheap motor. It doesn't have a little plug to undo, so what I'm going to do is apply a little bit of oil right where the shaft comes out of the bearing on both sides. Once I do that, I'm going to spin it by hand for a little while, and hopefully that quiets the air condition. If you enjoyed this video, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlists as well. Thank you very much for watching.